Good morning, guys. Today we're going over Chapter 9, Section 1, the Pythagorean Theorem. The Pythagorean Theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. Now, what does this mean? This means that we're going to have a squared plus b squared equals c squared as is stated right here. But which one's which? A squared will be a leg, b squared will be a leg, and c is always the hypotenuse. Now, the legs a and b can switch, so it doesn't matter if you put a first or b first. It is important to know that the legs must remain between a and b, and the hypotenuse is always c, but just be aware that you can switch up the a and the b. Now, these are some common triples. What does common triple mean? These are common triple triangles. So all of these are triangles. Now, we have, for example, triangle 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, and 25. And you can write them either up or down, doesn't matter the order. But just keep in mind, these common right triangles have something very important. They are right triangles, so they must be a right triangle. Now, if we write them, let's do 3, 4, 5. I can do 3, 4, 5. Key important thing right here. The hypotenuse is always, or has to always, be the biggest number. So if you were to write triangle 3, 4, 5 and you put the 4 here and the 5 here, that is wrong. The biggest number is 5, so that's a hypotenuse. And the next one is 10, in the following is 13, in the next one is 17, and the last one is 25. All of those are the hypotenuse. It's always the biggest. Now, for these examples, they want us to find x and y. Now remember, it's a squared. We're going to use the Pythagorean theorem plus b squared equals c squared. Now for a, example a, this is one leg and this is the other. So I'm going to plug this as a and this as b. So I'm going to get 5 squared plus 10 squared equals c squared. So this is going to simplify to 25 plus 100 equals to c squared. This is 125 is equal to c squared. So we're going to take the square root from both sides. I'm going to factor tree this to 5 and 25, 5 and 5. So we are left with that our c is 5 root 5. Now our c is the hypotenuse, which in this case is our y. So our y is equal to 5 root 5. Now, time to do b. We have, again, leg, hypotenuse. I'm going to plug the 5 in as the a, so I'm going to get 5 squared. Plus, now I'm going to have to do the whole term, y minus 1 squared is equal to y squared. So this is going to be 25 plus y minus 1 times y minus 1 equals y squared. I'm going to FOIL this, and it's going to give me 25 plus y squared minus 2y plus 1 is equal to y squared. Now I can subtract y squared from both sides, and they happen to cancel out on both sides. So I'm left with 25 minus 2y plus 1 is equal to 0. I'm going to go ahead and add the 2y on both sides, and I'm left with 25 plus 1 is equal to 2y. This is going to combine to 26 is equal to 2y. I divide by 2, and I get that y is equal to 13. So we found the second y. Now, as for this last one, I'm going to change the color, so make sure they don't overlap. I'm going to actually also erase right here to make sure I have some space. And let's solve for C. Now, C, we have this x is a leg, the 3 is a leg, and this is the hypotenuse. So, this is going to look as x squared plus 3 squared equals the square root, 3 square root of 2, all of that squared. Now, this is going to simplify to x squared plus 9 is equal to 9 times 2. So x squared plus 9 equals 18. I'm going to subtract the 9, and I get x squared is equal to 9. I take the square root, and I get that x is equal to 3. All right, for example 2, they want us to find the length of a diagonal of a rectangle. So, leg with a length of 8 and a width of 4. Now, if you notice, we're going to have 2 triangles, the green one and the red one. Now, keep in mind, we broke this rectangle into 2 triangles, which is completely fine. And they're asking us to find the length of this one. So I'm going to mark it as x. That is the hypotenuse for either triangle. So it doesn't matter if you put the 8 first or if you put the 4 first in the formula a squared plus b squared equals c squared. Again, so I'm just going to put the 4 squared first plus 8 squared equals c squared. Now x is c because it's the hypotenuse. So we're going to get 16 plus 64 is equal to c squared. 16 plus 64 is equal to 80. C squared, I'm going to take the square root of 80. This is going to simplify to 5 and 16. 4 and 4. So I end up with a radical of 4 root 5 as C. So my diagonal is 4 root 5. Or if you put x, our x is 4 root 5. The diagonals of a rhombus have a length of 16 and 30. And they want us to find the perimeter of the rhombus. So I'm going to draw a rhombus to the best of my abilities. We know rhombuses from the previous chapter intersect at a 90-degree angle. And they're telling us that they have lengths of 16 and 30. So the diagonal. So I'm going to say this is 8 and 8 because 8 plus 8 is 16. And 15 and 15 is going to be 30. So again, we're going to have 4 triangles. 1, 2, 3, 4. And we have the legs. Now, the hypotenuse is the outer perimeter of the rhombus. So I'm just going to find this triangle. I'm going to do 8 squared plus 15 squared equals c squared. That is 64 plus 225 equals to c squared. This is going to add to 289 is equal to c squared. And then I take the square root and get 17 is equal to c. Now, when we solve for it, the 17 is only for that one section. So, because we know a rhombus is equal throughout, I can do 17 for all of them. I'm doing this because they're asking for the perimeter, not just for the hypotenuse. So I have to do 17 times 4 to finish answering the question. And that's going to give me 68. So our perimeter for this rhombus is 68 equal to. Now example 4. They want us to find x. Now keep in mind this 6 belongs to all of it. So we can separate it into 3 and 3. So when isosceles, remember that the altitude is the bisector and the median. So I'll write that in so you guys have it. When an isosceles triangle, altitude is perpendicular, bisector, of its median. So now that we know that, we're able to solve for x because x is going to be the same for both sides of this triangle. So I'm going to do 3 squared plus 6 squared is equal to x squared. So it's going to be 9 plus 36 is equal to x squared. That's going to be 45 is equal to x squared. I'm going to take the square root and it's going to simplify to 3 root 5 x. Now, I do want to point out, how do I figure out which one's the hypotenuse every single time? I mentioned this, I'm going to repeat it. I mentioned it a few classes ago. It's always going to be the one across from the biggest angle. In this case, the biggest angle is 90, so that's why the x right here is the hypotenuse. Now we're going to do the converse of the Pythagorean theorem. So remember, this is just when we flip the if and then. So if the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So this is just stating that if they give us the sides and the equation right here works with it and it's equal congruently, then the sides are going to be equal, making it a 90-degree triangle. So we're working backwards. We're giving us a right triangle, and we had to find the sides. Now they give us the sides, and we have to find if it's going to be a right triangle. Now, theorem 9.3, Pythagorean inequalities theorem. This states if the square of the longest side of the triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. What does this mean? This is saying that if you were to solve this and you were to plug in numbers, if your C is smaller than, so hypotenuse, after you solve for it, is smaller than the other 2a plus b squared, then it's going to be acute. This is theorem 9.4, and it states another inequality theorem. If the square of the longest side of the triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. So what does that mean? If C is bigger than the other two sides, or the legs, added together and squared, then, or squared and added together, should be the right order, then it's going to be obtuse. In 40. So, they want us to find the length of the triangles, given and stated whether they're acute, right, or obtuse. So, if I set this up as, let's do the first one. 29 squared equals 20 squared plus 21 squared. This is going to give me 841 equals to 400 plus 441. 841 equals 841. So therefore, this triangle right here, this first one, is a right triangle. Now, if I do the same thing for B, I'm going to do 30 squared, not plus, equals 21 squared plus 20 squared. We're going to get that 900 is equal to 400 plus 441. So we get 900 it's equal to 841. So therefore, it's not longer equal. The 900 is bigger, which is the hypotenuse. Therefore, this one is obtuse. Now the third one, 8 squared equals 6 squared plus 5 squared. That's going to give us 64 equals 25 plus 36. That's going to be 64 equals 61. 64 is bigger, so we have that triangle C is also obtuse. For triangle D, we have 8 squared equals to 4 squared plus 4 squared. That's going to be 64 is equal to 16 plus 16. And that is going to give us 64 is equal to 32. Again, all of these are greater, so our fourth triangle is also obtuse. Now, the last one is missing a number. The number that is missing is the square root of 10. So, I'm going to do square root of 10 squared. That's the biggest one. You guys can check in your calculators. Equals 1 squared plus 3 squared. That's going to be 10 is equal to 1 plus 9. That's going to give us 10 is equal to 10. Therefore, this is a right triangle. Now, if by any chance we would have had the hypotenuse smaller, then it would have been an acute, but in this example, we didn't have any. And lastly, we have the summary of what we just saw throughout this whole PowerPoint. We have theorem 7.2, 7.3, and 7.4. This is state 7.2. If it's equal, then it's a right triangle. If C is less, then it is an acute. And if it's greater, then it's going to be obtuse. Now, guys, you do have homework tonight. It will be on Canvas if it's not up yet already. And I'll see you guys tomorrow.